on them, we call them cations, and which have negative charge on them, we call them anions. So we have two type of charged particles and we call them ions. How these charged particles are formed? Now let's see here. As I told you, the elements which have negative charge, we call them anion. For example, chlorine. And the atomic number of chlorine is 17. If I write its electronic configuration, it is 287. So to exist in nature, to get stable in nature, these elements either they transfer their electrons or share their electrons, or they, in this manner, they lose or gain some electrons. So here in the outermost shell, 7 electrons are there, and there are two conditions to be stable in nature. Either they have 2 electrons in their outermost shell or 7 electrons or 8 electrons in their outermost shell. So there are two conditions. First is if they have 2 electrons in their outermost shell and 8 electrons in their outermost shell. But if we look at the electronic configuration of chlorine, it has 7. So it means it is not stable in nature. So what it will do, either it will take 1 electron or lose 7 electrons. So out of these two, which one is more easy? Taking 1 electron. So we'll consider this one. So this chlorine, if it takes 1 electron, if an element is gaining electron, so it attains negative charge on it. So this is how these elements have charges on them. And on the contrary, if we are talking about positively charged ion, these are known as cations. Look at the example of sodium. Its atomic number is 11 and electronic configuration is 281. We'll study about these valencies later in the forthcoming chapters. So to be stable in nature, this sodium also needs 8 electrons in its outermost shell. And it has only 1. So again there are two conditions, or there are two options we can say. Either it will take 7 electrons or lose 1 electron. Again, which one is the most easy task? Yes, now write down in the comment box which one is the most easy task. Gaining 7 electrons or losing 1 electron? Yes, so losing 1 electron is the most easiest task. So in this manner, this sodium loses 1 of its electron and its electronic configuration now becomes 2A. Now it is stable in nature. So here in this case, it is losing 1 electron. So if it is losing 1 electron and it attains positive charge on it. So as you can see, if element gains electrons, it has negative charge and we call them anions. And if an element loses electrons, it attains positive charge and we call them cations. So I hope this concept is clear to you, how these charged particles, or we call them ions, are formed. So by gaining or losing electrons. And for that, they need to be stable in nature and they have to attain these two conditions. And for attaining these two conditions, either they are losing electron or gaining electrons. And whatever electrons they are losing or gaining, according to that, they have different charges present on them. Here in both the cases, they are losing 1 electron only and gaining 1 electron. So that's why they have Na plus and Cl minus only. But if we take an example of another element, suppose we have aluminium and its atomic number is 13. So I'll write its electronic configuration, which is 283. Now tell me which one is the easy task. If this aluminium wants to be stable in nature. So there are two conditions which we have already discussed. So either lose 5 electrons, take 5 electrons or lose 3 electrons. So there are two conditions. Now write in the comment box and tell me which one is the easy method to get stable in nature. Whether it will lose 3 electrons or gain 5 electrons. Now tell me quickly. Okay, yes. See, because we always go for less number. So here, losing 3 electrons is much easier one because it needs less energy. So here, this aluminium lose 3 electrons from it and its valency is 3. So here it is losing. It means because aluminium is quite very good, he always give electron. So the elements which are good in nature, they are always care about others. They lose their electrons, they give their electrons, and they attain positive charge. So here aluminium attains 3 positive because here it is losing 3 electrons. So it becomes aluminium 3 positive. So I hope this is clear to you how these elements attain these kind of charges on them. Okay. Now, what kind of question can come in the exam? Either the question can come, write down the charges present on these elements. So you need to write these charges, and this is the method how will you represent those charges on the elements. In another way, question can come like the atomic number of 3 elements A, B and C are 9, 10 and 13 respectively. Which of them will form a cation? Now first of all we need to know what is the atomic number, which is already given, and we should know how to write their electronic configuration. So first 9. The first element A, which has atomic number 9, I'll write its electronic configuration. So here is the electronic configuration 2 and 7. Now electronic configuration of B is 2 and 8. And electronic configuration of C is 2, 8, 3. It has 9 electrons, it has 10 electrons, and it has 13 electrons. Now look at these A, B, C. This is A, B and C. To be stable in nature, everyone will fight. Now look at this B. It is already complete. The outermost shell is already complete. It already has 8 electrons in its outermost shell. So this B will neither lose electron nor gain electrons. So this will not be the answer. This is not a cation. And if the outermost shell is completely filled, those type of elements are known as inert gases because they will not react with any other substance. Okay, now we have only 2 left, A and C. Now look at electronic configuration of this A1. In its outermost shell, 7 is here. So it will take 1 electron. And if it is gaining 1 electron, it attains negative charge on it. Look at the example of C1. It has 2, 8, 3. So it will lose its 3 because that's now I have discussed for gaining 5 electrons they need tremendous amount of energy. So this energy cannot be created. It is not an easy task to create that amount of energy. So we always go for easy options. So these elements are very smart and they always opted for the easy options. So here this electron, this C1, it will lose 3 electrons. And being good in nature, it is very caring in nature. So it loses 3 electrons, and if it is losing electrons, so it attains positive charge. And whenever any element has positive charge, it becomes cation because here they are losing electrons. So I hope this type of question is clear to you. And if in exam these kind of questions can come, it is very easy for you to tell whether the element has cation or anion. For that, you need to learn atomic numbers. So at least learn atomic numbers till 1 to 20, and then you should know how to write their electronic configuration, and detail of this electronic configuration I'll do in next chapter, how to write electronic configuration of these elements. So here just understand, if an element is losing electron, so it attains positive charge, and if it is gaining electron, it attains negative charge and it becomes an ion. Okay, so I hope this is clear to you. Now comes to next topic, valency. As I told you, these elements, either they are gaining or losing electrons. That combining capacity of an element to lose or gain electron is known as its valency. Suppose if an element loses 2 electrons, so its valency is 2. And if an element is gaining 1 electron, its valency is 1. Only there is a difference in the charges. So if the element is losing or gaining electron, that tendency of losing or gaining electron is known as its valency. And why they are doing this? As I told you, to be stable in nature. Otherwise, they will not exist in nature, but they want to be exist in nature. They want their existence. So that's why they lose or gain electron from nearby elements. So I hope this is clear to you, valency. Now, if an element consists of 1, 2 or 3 electrons in its valence shell, then its valency is 1, 2 or 3 respectively, which I have just explained. I have taken example of aluminium here. Aluminium 2A3. So it has 3 electrons in its valence electron. It has 3 electrons in its valence shell. So its valency is 3. Okay. So if an element consists of 5, 6, 7 electrons in its outermost shell, its valency is 3, 2 or 1. No need to learn these things. If you know how to write electronic configuration, you can easily find out their valency. So it's very easy, that I'll discuss later with you. And sometimes if an element has 4 electrons in its outermost shell, then in this case its valency is 4. And this is an exception. Carbon is an exception. It share electrons, and this tendency, this we will discuss about carbon in carbon and compounds chapter in detail. So, and if an element has 8 electrons in its valence shell, its valency is 0, because it will not require any other electron to be stable in nature. And if its outermost shell has 2 electrons, then also it does not react with any other. It is also called inert gas. In example, helium. Atomic number of helium is 2. And if I write the electronic configuration, it is 2 only. So helium is also an inert gas. So these are the various steps when we are writing valence electrons or valency. Then due to the losing or gaining of electrons, they attain some formulas, and those are known as cations and anions formula. Now let's look at the example of these. Hydrogen, it has H positive. So you need to learn this table by heart. If you will not learn this table, you will not be able to solve the forthcoming topics, which are chemical formula, molecular formula, and then formula mass unit. So you need to learn this table. It is extremely important. It is given in NCERT book also. So learn this table by heart. You should know their formulas of all the cations and anions. So let's discuss these formulas one by one. Sodium Na positive, and how these formulas are formed. Just now I have discussed this is due to the tendency of losing or gaining electrons. Then silver, that's Ag plus, potassium, K plus, lithium, Li plus, ammonium, NH4 plus. Just learn these formulas. Barium, Ba2 plus, calcium, again Ca2 plus, copper 2, Cu2 plus, magnesium Mg2 plus, then zinc Zn2 plus, lead Pb2 plus, iron 2, iron 3. Sometimes, elements exist, these metals exhibit more than one valency, and that is known as variable valency. That is known as variable valency. If they'll show more than one valency, like in case of iron here, copper also shows this valency, that I'll discuss later. Then aluminium, Al3 plus. Now comes to chloride, Cl minus, bromide, Br minus, fluoride, F minus, iodide, I minus, hydroxide, OH minus, nitrate, NO3 minus, oxide, O2 minus, sulfide, S2 minus, sulfate, SO4 2 minus, carbonate, CO3 2 minus, hydrogen carbonate, HCO3 minus. Look at the difference, carbonate and hydrogen carbonate. So you need to learn all these formulas by heart. Learn it. Learn this table. It is extremely important. Now, if they have only one charge on them, we call them monovalent. And if they have positive charge, we call them monovalent electropositive. And if they have two, we call them bivalent electropositive. If they have three, we call them trivalent electropositive. And if they have four, we call them tetravalent electropositive. So depending upon the charges present on them, we have these monovalent, bivalent, trivalent or tetravalent. Look at these examples. Fluoride, chloride, bromide, iodide, OH plus, NO2 plus, NO3 plus, H3O plus. So if they have one, monovalent. If they have two, we call them bivalent. And three, they have trivalent. And four, they have tetravalent. You no need to learn this mono, bi, tri, tetra. Just remember, one means mono, two means di, three means tri, 4 means tetra. Only this table you need to learn. Now these are the name of the element, their symbol and their valency, which I have already discussed with you how they attain this valency. So the tendency or the capacity of the elements to react with other, to lose or gain electrons is known as valency. The combining capacity of an element so that it will be stable in nature is known as its valency. Here are examples in front of you, and look at few elements where only this dash is present. So it has valency 0 because atomic number is 2 here. So its outermost shell is completely filled. So it is an inert gas. Same with neon. So they don't require any further electron to be stable in nature. So that's why their valency is 0, because they are neither giving electrons nor gaining electrons. So that's why they don't have any charges on them. And if we talk about carbon, which is an exception, and this property is known as catenation, so which I'll discuss in carbon compounds chapter, it share electron because its valency is 4. So I hope till here it is clear. Now sometimes some elements show more than one valency, and we call them as variable valency. In examples of such kind of metals are iron, which has valency Fe2 plus and Fe3 plus. So we call it iron, in bracket I'll write 2 like this, and if iron 3 is written, then you need to write this Fe3 plus. So remember, if Fe2 is written, so it means it is Fe2 plus, and if it is Fe3 is written, so then in that case you need to write this valency Fe3 positive. So I hope till here it is clear. Now similarly with copper also, copper symbol is Cu, and if I'll write 1, then its valency is Cu plus only. And if it is given like this, it means we are talking about copper 2 and its valency is 2 positive. So these elements or these metals which shows more than one valency, they are known as variable valency. Now, question can come in exam, write down the valency of the following. So you need to learn that formula, that table which I have already told you. Like, write down the valency of magnesium ion. So if you know this table, you immediately write down the formula and you know whatever charge is present on it, so it has valency 2. Ammonium. Ammonium. Where is ammonium written? Here. Here it is ammonium. If you know its formula, which is NH4 plus. So this charge shows the valency. Don't get confused with this one. It will not show valency. The number which is written above here, that shows the valency. So it is plus, only plus, so it means it has only one valency. So it has valency 1. Carbonate. Look at carbonate. It's CO3 2 minus. Look at this number only. Don't look at this subscript 1. Only this number shows the valency. So carbonate CO2 3. So here valency is 2. Then we have nitrate. Nitrate. Here it is nitrate. NO3 minus. So again, only one is here. Only minus sign represents, it means it has only one valency. Oxide. O2 minus. So it has 2 valency. Okay. Oxygen atomic number is 8. Just write down its electronic configuration. And it needs 2 electrons to be stable in nature. So it gained 2 electrons. So that's why it has valency 2 minus. Understood? So when we are writing valency, we are not writing charges. Remember, this is very important point. Whenever you are writing valency, don't write any charge. Okay? Now, aluminium ion. It's Al3 plus. Its valency is 3. So when you are representing valency, don't write on this. And if they are asking whether it is cation or an ion, then you have to mention the charges. Okay? I hope this is clear. These are the symbols or the formulas of these positive or the negative ions. Now next is chemical formula. When you are writing chemical formulas of molecular compounds or ionic compounds, there are certain rules which you need to follow when you're writing chemical formulas. We are saying water. So we are writing this formula water this. But how this formula is made? If we are writing carbon dioxide, we know this formula CO2. If I'll say, what is the formula of methane? You'll say CH4. Ma'am, it's CH4. But how do you know it's CH4? How will you write this chemical formula? So there are certain rules which you'll follow when you're writing these chemical formulas. And what are those rules? So first of all, I'll discuss about molecular compounds and ionic compounds. There are 2 types of compounds, molecular and ionic compounds. But what is the difference between these 2 types of compounds? Molecular compounds are those compounds which are formed by the sharing of electrons. For example, NaCl. Here, not NaCl, like HCl. So here they are sharing electrons. And ionic compounds, when there is a transfer of electrons. An example of such kind is like NaCl, ionic compounds. Ions are there. So the difference between molecular and ionic compounds is molecular compounds are formed by the sharing of electrons and ionic compounds are formed by the transfer of electrons. Now what are the rules when you are writing chemical formula? First is the valencies or the charges. if we are talking about molecular formula, first I'll discuss rule related to molecular compounds. First step is write down their symbol. Whatever symbol do they have? Let's take an example. HCl, hydrochloric acid. In exam it is given, write down the chemical formula of hydrogen chloride. They'll write like this, hydrogen chloride. Then you start thinking, okay, what is the formula of hydrogen chloride? But few formulas, you know their formulas, but there are steps. You need to write those steps also. So, but you know the symbol of hydrogen. Symbol of hydrogen is H. And look at the name, hydrogen chloride. It means two elements are involved, hydrogen and chlorine. And symbol of hydrogen is H and the symbol of chlorine is Cl. So first step is write the symbol of the elements. Okay. Now after writing their symbols, now write down their valencies just below them. Valency of hydrogen is 1. Its atomic number is 1 and its valency is 1. And valency of chlorine is 1. Just remember its electronic configuration, 287. So it loses 1 electron. So its valency is 1. Okay. Now don't write any charges here. It's a molecular formula we are writing. These are molecules. Now next step is just cross these valencies. H1 and Cl1. They both are same, so we can easily cancel out, and its formula is HCl. I hope it's easy. So these are the steps when you are writing their chemical formula. So these are the rules for writing chemical formula for molecular compounds. Okay. Now next is, what are the rules for writing the chemical formula for ionic compounds? Although rules are more or less same, but the difference is when we are writing ionic compounds, because they contain ions or charges. So in that case we need to write. Here no charges are present, so we are not writing any charge. We are simply writing their valencies. Okay. But if you are talking about ionic compounds, we'll write their charges. That is the only difference. Otherwise the entire rule is same in both the cases, whether we are writing for molecular compounds or for ionic compounds. Let's look at the example of ionic compound. NaCl. NaCl. When it dissociates into ions. So that is Na positive. Sodium 281. So it is losing 1 electron. That's why I've written positive charge. Now here chlorine. In this case, these are formed in the form of ions. That's why they are ionic compounds. So it is Cl minus. Again 7. Now in this case, if no number is mentioned along with their charges, it is clearly understood that it has only 1. Okay. Now just again crisscross. It means it has plus 1, it has minus 1. So if we'll crisscross, then it is NaCl. And when we are writing chemical formula, we never write charges on them. Because, to be stable, in ionic compounds, positive charges are always equal to negative charges. And when they both are equal, it becomes neutral. So whenever you are representing any chemical formula in ionic compounds also, we never use any charge. So in this manner, you'll not write like this. This is not a chemical formula. Don't write like this. Chemical formula is NaCl. It means positive and negative charges both are equal in number. Okay. So these, and if It contains polyatomic ions. Polyatomic ions means here it has only sodium and it has only chlorine. Only one atom, one element is involved into it. But if it contains polyatomic ions, for instance, SO4. So here it contains S and O, 2. So it is a polyatomic. So we always write that polyatomic ion in brackets. Okay. So this is the rule. Now, how to write chemical formula of some simple compounds. First is calcium hydroxide. Okay, before writing this, I'll give one example to you so that it is very easy for you. Like first I'll clear this out. H2SO4. It contains H and SO4. SO4. Look at this table. SO4, which is sulfate. SO4. And its formula is SO4 2 minus. And hydrogen is 1. So I'll write like this. SO4. Then I'll crisscross it. Fine. Now after crisscrossing, it is H2SO4. No need to write in the bracket because it's only 1. And if it is more than 1, then we'll use bracket. That example I'll take later. Those kind of examples also I'll do. So I hope this is clear. If polyatomic ions are present, then how will you present or how will you write chemical formula? Fine. Then next is chemical formula of some simple compounds. Look at the example of calcium hydroxide. Again and again I am saying learn this table, otherwise you'll not be able to write chemical formulas. So first is calcium. Look at calcium. Here it is. First write down the symbol calcium hydroxide. First write down the symbol of the elements present in that compound. Calcium represents by Ca and hydroxide. Hydro, H, oxide O. It means OH is present. Okay. So first I have written their symbol Ca and OH. Now look at their valency in the table. Calcium, it has valency 2 positive. So just below this calcium, I have written +2. And just look at the valency of hydroxide. Where is hydroxide? Here is hydroxide. So OH minus. Again, OH minus means it has valency -1. Okay. So I have written -1 just below this OH. So second step is write down their valency just below these elements. And then crisscross. Then crisscross their valencies. Now, if I'm crisscrossing it, this 2 comes with this OH and this 1 comes with Ca. So no need to write like this. Don't write down like this. As I told you, if it is more than one number, so we need, and it is polyatomic. Just see, polyatomic. It has oxygen and hydrogen. So according to rule, if it has polyatomic ions, so we'll write that polyatomic in bracket. And this 2 comes with this hydroxide. And no need to write 1 here. It is understood. So you'll write formula like this. CaOH2. So I hope it is clear to everyone how to write this. Another example is aluminium oxide. Aluminium oxide. Again, write down the symbol of elements involved in that compound. From the name, you can easily make out which elements are present in it. Aluminium oxide. Oxide means it contains oxygen. Aluminium, you know very well. So I have written aluminium and oxide. That oxygen is represented by O. Now look at the table. Aluminium. Where is aluminium written? Here it is. And its valency is 3 positive. So I have written plus 3 here. Oxygen, it means oxide. It has 2 minus. So I have written minus 2 here. And then crisscross their valencies and we'll write like this. Al2O3. So look at this formula. When I'm writing formula, I'm not using any charge. So don't do this mistake. When you are representing any formula, don't write their charges. Okay? And this is not polyatomic ion. That's why I have not, apply any bracket here. So the formula of aluminium oxide is Al2O3. It's easy. Then, now there are certain more examples. Write the chemical formula of sodium carbonate, aluminium sulfate. Okay, now listen. Before this, I discuss these chemical formulas. I'll give you few questions for homework. So write down chemical formula of those elements, and I'll discuss those compounds in next class. So I'm writing here, solve chemical formulas, magnesium chloride. I'm giving you this homework. Okay. Yes, I'll write here. Magnesium chloride. Very simple, I'm giving you. Magnesium chloride. Then write down potassium permanganate. And then write down for calcium hydroxide. It's calcium hydroxide. And if you know, just write on that comment box so that I can see whether this topic is clear to you or not. Although in next class I'll discuss few more examples. And one more I'll give you, that's sodium nitrate. Try to write chemical formulas of these compounds. This is your homework. Try to solve or write down chemical formulas. Okay. And when we'll meet in next class, make sure that this table should be learned. If you don't know this table, then it is very difficult for you to write down these formulas. So I'll take these questions in next class and I'll discuss each and every chemical formula. This is your homework, so solve it yourself. And if you'll not be able to solve, don't worry about it. I'll discuss all these questions in next class. And apart from this, I'll discuss more questions along with it. So learn this table. Okay. I'll just show which questions I'll discuss in next class so that you'll be prepared. So these I'm going to discuss with you in next class. So learn these cations and anion formula, and these are 1, 2, 3 and 4. Okay, so these 4 you'll solve yourself, and if you know the answer, write in the comment box right now so that I can see, or take your time because today is the first class for this chemical formula and it is extremely important topic.